Welcome to Pre-Calc Lesson 1.2, Lesson Summary. In the explorations that we did in class today, we explored different types of symmetries for relations. In particular, symmetries with the x-axis, the y-axis, and symmetry with the origin, also known as rotational symmetry of 180 degrees. That was for relations. Hopefully we have the time to also explore even and odd functions. When it's more than a relation but actually a function, it passes the vertical line test, then we can determine if the function is said to be even or odd, which again is related back to the symmetry. In class, you observe that some functions have symmetry, but they can't have all three of these symmetries. For example, we can have a function that has symmetry with the origin. This function, if it was rotated 180 degrees, it is a function that passes the vertical line test. It would have symmetry. And that would be, we consider this to be an odd function. We also looked at even functions. Even functions will have symmetry with the y-axis. For example, take a look at this quadratic, which has a degree of 2. It is symmetric across the y-axis. It is a function. Now, things that are not functions could have symmetry with the x-axis. For example, if I had this graph right here, this is not a function, but it does have symmetry with the x-axis. So it's neither even or odd. We'll be looking at this more carefully in this video, and the specific algebra test to determine first if a relation has x-axis, y-axis, and/or origin symmetry, and secondly, if a function is even or odd. On this graph, you can clearly see that the points are reflected across the x-axis, so this has x-axis symmetry. However, there is a test that we can do algebraically. The test if something has x-axis symmetry, we will do the opposite of y. To test, and so what that looks like is this: x minus y squared equals 1. In place of y, we are substituting the opposite of y. When we plug that in and we square, negative y times negative y is positive y squared. And so we end up with the exact same function. If the functions are the same after plugging in the opposite of y to test for x-axis symmetry, then the function has x-axis symmetry. But only if the algebraic equations are the same after doing this. The next function is one, or not function, the next relation, these are relations. The next relation actually appears to have y-axis, x-axis, and rotational symmetry. So we will look at the test for those. Remembering the test for x-axis is to substitute the opposite of y. So in this equation, I have x squared plus y squared equals 25. In place of the y, I'm plugging in the opposite of y. When you square negative y times negative y, you get positive y squared. This gives us the exact same equation. So it does have x-axis symmetry. For y-axis, similarly, we'll plug in the opposite of x. So into this equation, we have x squared plus y squared equals 25. That's our original equation for this relation. And we're plugging in the opposite of x. When I plug in the opposite of x and square it, I get x squared plus y squared equals 25. Giving me yet again the same equation. So yes, it has symmetry to the y-axis. And lastly, we're going to check for symmetry with the origin. In this case, a rotation of 180 degrees would be equivalent, if you remember from geometry, So a reflection across both the x-axis and the y-axis would give us the rotation of 180 degrees. So we have to test the opposite of x and the opposite of y in the algebraic equation. So our original equation was x squared plus y squared equals 25. When I plug in the opposite of x and the opposite of y and square them, now if this were a fourth degree or sixth power exponent, then it would still come out positive, but if it was odd, then it would come out negative. But because it's squared, it comes out positive. An even power, even number of negative sides, sign gives us a positive product. So once again, we're back to the original equation. So yes, this circle or this relation has x-axis, y-axis, and origin symmetry. The algebraic test for relations with symmetry for x-axis, plug in the opposite of y for y-axis, plug in the opposite of x. For origin, plug in both opposite of x and opposite of y. And for them to have it, for all three of these, for each one of them individually, you must get the original equation or it doesn't have that symmetry. Next, we're going to look at functions, even versus odd functions. Algebraic test to determine if a function is even or odd. Well, you're going to plug in the opposite of x. So you have a function f of x, and you're going to plug in the opposite of x. If in doing so, you evaluate it and the negative goes away and leaves you with the original function, it's back to the original function. So again, this only works for functions. That's why I'm using the word function now. Then it is said to be even. Have be an even function. If you plug this in and instead you get the opposite of the entire function. So for example, we started out with a function of x cubed minus x, and that was a function. And we plugged in the opposite of x, which in effect made this opposite of x cubed plus x. Every sign, the sign on each coefficient, every term has changed. Sign on all terms changes. Then it is said to be an odd function. That is the test for whether a function is considered even or odd. Let's take a look. Oh, by the way, it could be neither as well. Let's take a look. In this function, I have opposite of x cubed minus 2 times the opposite of x. Negative 2 times opposite of x is positive 2x. Negative x cubed is negative x cubed. This sign is the opposite. This sign is the opposite. Since it's changed signs, this function is odd. In the next function, I plug in the opposite of x, and I end up, when I raise it to the fourth power, I end up with positive x to the fourth plus 2. Because it's the same function, exactly, this is an even function. In example A, it was the opposite signs on all. Here, it was the exact same equation, so it's an even function. And then our last one, I'm going to do the opposite of x cubed minus 0.5 times the opposite of x squared minus 3 times the opposite of x. Here, the sign will change, making it positive 3x. Here, it will stay negative 0.5x squared, and here it will become the opposite of x cubed. In this equation and this equation, The only ones that have changed signs are the last term and the first term. The middle term does not change signs. So we cannot say that all the signs on all the terms are opposite. Therefore, this is neither. Once again, the learning target for this video was for you to understand how to use the test to determine if a function is even or odd, and how to test 3 different ways for a relation, whether it has x-axis symmetry, y-axis symmetry, or origin symmetry with origin. This concludes the follow-up to our exploration for lesson 1.2. Have a great day.